All right. For those, I didn't start the recording till now. There was a question on test one, reading some things, and I figured this was it. This is the first page of test one of a two-page test, and it's a lot of blanks on it, so there's lots of potential points here, so go for it. Number 6, when I was first doing this, I just typed it, or in fact, I just got it off the test bank. And this is exactly what it said. Find the exact values of the 6 trigonometric function of the real number t at the point in standard position 7/13, 8/13. That's how it read. Okay? And then I looked at their answers, and their answers were wacko. Okay? And the reason they were wacko was they meant this to be on the unit circle. Well, obviously, 17/13 is not on the unit circle. 8/13, yeah, that could be. 17/13 is greater than 1. It can't possibly be on the unit circle. So, judging from the answers they gave, I knew what point they really meant. They meant it to be 15/17, 8/17. So rather than having to change the key, I just changed the number. So that point there is 15/17 is the x value, 8/17 is the y value. And then if you were to go and, in fact, I'll do it for you just to make sure I haven't made a dumb mistake. If you square 15, I'll unplug my phone, it's fully charged now. All right, so I'm going to do 15 divided by 17. Oh wait, I've got to check. Well, divided by 17. Okay, equal. That's a decimal number. I'm going to square it. Okay, and then add to that 8/17. 8 divided by 17. I should have put parentheses. Sorry. I'm going to have to start over. Okay. I can do the first one like I did. 15 divided by 17 equal, square it, plus, okay, well, that messed up too. Something's really screwing up here. 15 divided by 17 equal, oh, I hit a square root key rather than a square key. Okay, I squared it. Okay, plus, now on this calculator I have to open parentheses. Open parentheses, in fact most of them I think you would. 8 divided by 17, 8 divided by 17. Close the parentheses, square that, and then hit equal, and sure enough you get 1. So I am on the unit circle. Oh, here comes Izora. Okay, let me get Izora in here. So sure enough, I didn't make a mistake. That point is on the unit circle. Okay, that was all I wanted to verify that I was saying it correctly. And I've already done that before, but I just wanted you to see what my thought process was. Let me mark Izora here. Here we have Izora. Okay, now that gets me up to 11 students. Let's see if I got them. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. Okay, I don't see anyone else waiting. Let me make sure there's nobody else waiting. Okay, now for those who just came in, and I think somebody may have a microphone on that you don't realize it. For those who just came in, the question was on test 1. I pulled it up and showed it to you. Question 6, that thing, they had this thing on the test bank, and their answers were for this problem. So I just changed the problem rather than changing the answers. So the point is 15/17, comma 8/17. And that is, I just verified, a point on the unit circle. So does that answer your question? Good. All right. And so unless there's other questions on the test, I'm going to close it out now. Is that okay?
I have a question.
Yes.
Where do you go to find this? Because I've been trying to find it for a while. I don't know.
Oh, to find the test?
Yes, sir.
Okay, that's a good question. Very legitimate question. Any others on the test before I close out the test? Okay, I'll close them out. If you have others, it can come back. All right, so that question is a Blackboard question. So I think it's in two places. I'm going to have to verify that. I had to do the same thing with my first class too. It's going to take a while for me to get this up. I thought I had it up there, but evidently it closed out. I know what happened now. Unfortunately, this is going to take a while to do because Blackboard is slow. This computer's slow. It's a fairly new computer, but it's slow. I know screen sharing has stopped, so yeah, fine with that. But I've got to get Blackboard open before I can do screen sharing again. So hang on, Sloopy, we'll get there. And these always have to resolve host, and I don't know why. My wife says it's something to do with the computer, because most computers of this vintage should come up a lot faster than this one does. So evidently they have so much loaded on it. This is not my computer. It's one issued by the college. They had it down in the same office that does the distance ed, so I guess they have all their training on it. I don't know. I can't tell, but it's still trying to resolve the host. So I'm sitting here watching new tab go around and around in circles. Hopefully it will open one of these days. My internet is good. I've got 5 bars and internet access, so there shouldn't be a problem there. Now I have heard this week that there have been difficulties with internet. My wife said at UAB they were having difficulties. I know in several of my classes oops, that's not what I wanted. Let me close this out. Okay, I wanted to check and make sure nobody else was waiting, and I can't see that. Everything is slow. Goodness gracious. There we go. Nope, no one's waiting. 11 students. 1, 2, 3, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. Yeah. We got everybody here who's here so far. And Blackboard is, well, it's not Blackboard. Lawson State's not opening. I go through Lawson State to get to Blackboard. Have any of you had trouble getting into the onto the campus website today? I've been on it 2 or 3 times and it's never taken this long. So I don't know what the problem is. I wonder if I ought to shut it down and try again. Any of you have any suggestions? Yuck.
Hit the refresh button.
And that's which one? It's usually one that's too little. Oh wait, here it comes. Here it comes. Okay, good idea, but let me minimize y'all folks for a minute so I can get to Blackboard. That just got me to the Lawson State webpage. Let's see how long it takes to get to Blackboard now. It was much faster this morning. I did emails this morning. In my first class, I did the same thing. Had to go to Blackboard to show them where the test would be located. I had not put theirs out yet, but one of them said, where are the YouTube videos, which I've gone over I don't know how many times. So I was showing them that, and how do you find it. So I went through the whole shebang. Yep, this is taking just as long. Now I'm down to 4 bars, but I still have internet, I think. Yep, still have internet access. So Now, is there a refresh button? Would it be on my screen now? You can't see my screen, I don't guess. But where would it be? Isn't it the one that's two little arrows in circles? Isn't that refresh? Or what does a refresh button look like?
The little circle, the arrow look like one of the circle on top.
Yeah. Yeah, and I don't see it on this screen, so I obviously can't refresh here. And since the employee port, say again, F5?
F5.
Okay, let me see. F5, let's see what happens there. Ha! That took me right to it. Good news. Was that also a refresh?
Yes, sir.
Wow, thank you. See, y'all are teaching me a lot of stuff. Okay, let's see if I can get into Blackboard then. It may take just as long as the other did. Well, should I do it? Yes.
When's the test gonna be at? Like, what time is gonna be up on there?
Okay. Where is it on Blackboard? Is that what you're asking?
Yes.
That's what I'm trying to show you. If I could ever get Blackboard to open. In fact, I'll share the screen with you to let you see how it's just sitting here trying to open. Should I hit refresh again? Would that be your suggestion? Wait a minute. Yeah, I'm recording. Okay. Okay. Oh, I hit the wrong key. That's what I was doing. Sorry about that. I meant to hit zoom. I hit the screencast-o-matic. Well, zoom seemed to be doing nothing. Oh, wait. Forget that. It finally opened. Okay, let me go to courses. And let me scroll down and find this course. Once I do that, then I will, yeah. Okay, now I'll go back to Zoom. I don't know why there's two Zooms open. I can't get either one of them to do anything. There we go. That's not the one I wanted. I want the other one. Boy, this is being awkward today. Okay. I cannot get Zoom to open. I don't know if I'm going to have to go back. Okay. Return the meeting. Let me try that one. Yes, there we are. All right, now I'm going to share the screen with Google Chrome. All right, can you see my Blackboard here? My course list. Okay.
Yes.
All right, I'm going to try to move Matthew. You're in the way. I'm going to scoot you to the right. Okay. So I'm going to click on Math 113. That's our class. Okay. And there was our announcement. Okay. It's going to be in two places. I'm going to go to the first one. Now, I got to move y'all out of the way. Terrell, you're in the way again. Okay. I'm going to go under weekly assignments. Okay. Now, going to scroll down here, and I'm pretty sure I put it in week 6. If it's not there, it's in week 5. So I'm going to click on week 6 to open it. I really do not like this template that they make us use now. Yeah, there it is. Under week 6, you see test 1. See that? Under weekly assignments, week 6, test 1. Click on that. And let's see if it's there. It may not be there. Let's see. No, it isn't. And here's why it's not. Because they did not put, whoever put this template together did not put us an ability to put anything in. There should be a little plus sign here. There is no plus sign, so it's not there. So there's where the woozle wasn't. Now there's where I'll put the grades, but the test won't show up there. Okay, sorry about that. So here's where the test is. Okay, I'm going to close week 6 and close the weekly assignments. I don't have to do all this, but it just, they bug me being open like that. All right, then I'm going to scoot as far north as I can, and I'm going to move Jalen, you're in the way again. Don't scoot you over here. So at the top of the page, you see this envelope? It says messages. Okay, whoever asked the question, do you see this?
Yes, sir.
Okay, click on the messages. There it says, attached is test 1. I tried to post it in week 6, test 1 tab, but Blackboard would not let me do that. So I had to post it here under messages. I told you I'd do it both places. It's only one. Click on my name. You see it's underlined with the icon by it. So click on my name, and there it is. Now, in order to open it, if you try to open it here, it won't do because it doesn't underline, even though it has an icon. So you have to come to the 3 dots here, and when you click on those 3 dots, they call it an elliptical. I don't know why. It says download original file. If you click on that, then you see down in the lower left corner, you see it start downloading. When it finishes downloading, open it there. Okay? Does that answer your question? Okay. Okay. Yeah, that's I don't know. I mean, most of the items they have out there, they have the little plus sign. This one they did not. It's okay. It's an open book, open notes test. Do your best, turn it in. Okay? All right. I don't want to have to grade it 3 or 4 different times, everybody. I never leave the office up here. My wife's already complaining I'm here too much. So I don't want to get in any more trouble at home. So we're going now. So what I'm going to have to do is move. Well, let's see if I can do it here. Yeah, I shut it down, and I'm going to get out of any other Blackboard questions before we leave Blackboard. Okay. Then let's go back to, let's see if anyone else is waiting. I don't see anybody. Sort of a small crowd today. This is usually a really well attending class. I'm glad y'all are here though. So let's go to a new share here. And now we're going back to 4.5. Okay. Now I think that's where we left off last time. Any other questions before we get started on trig today? So we'll do this from current slide, and Q1, you're in the way again, so I'm going to scoot you over to the left, and I think we're ready to go now. So let me make sure just one last time that nobody's waiting. I don't see it. I should have 11 students here. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. So I feel confident. I had a guy, and one reason I keep checking, I had an email this morning. A guy in my first class said, I tried to get into Zoom and it wouldn't let me in. Can you give me a call and let me know what you did? Well, I didn't have time to give him a call because I only like 4 or 5 minutes before class started. So I just shot him an email back and said, well, the class is recorded. It's out there on YouTube videos. There were 20-some people there in that class, so I know Zoom was working. So it may be that it was his internet. I don't know what it was, but he said Zoom wouldn't let him in. I check all the time to make sure nobody's waiting. So, and it's not the first time he's done this. I don't know. Makes me wonder though. Okay, let's hit this. We're in chapter 4, trigonometry. We're in section 4.5, graphs of sine and cosine functions. On page 297, right at the beginning, this figure down here, I don't know if you can see it, I can't, it's, you can see the whole name for it, figure 4.36. The black portion here is what we call, of that graph, represents one period of the function. It's also called one cycle of the sine curve. This is y is equal to sine x, and here is how sine x looks. It repeats itself over and over and over again, infinitely to the left, infinitely to the right. Domain is all real numbers. It's there, and it just keeps going back and forth between plus 1 and minus 1, plus 1, minus 1, plus 1, minus 1, exactly the same pattern. It's a repeating curve, so we call it a periodic function, okay? And this is one period. From where it starts here, not to the next zero, because at this zero you're going uphill, at this zero you're going downhill. So it's not that one. You have to go to the next zero that is going uphill exactly the same way that is. That's what defines one period. Okay, now one period could have started up here at the peak and gone to that peak. That would have been a period. It could have been from this zero to that zero would have been a period. It could have been from this valley to this valley would have been a zero. It could have been from this portion right here to the corresponding point over here. That's one period, one cycle of the sine curve. Okay, now the gray portion of the graph indicates the basic sine curve forever. And notice it doesn't end, it just keeps on going, keeps on repeating that same periodic fashion. Okay, it keeps on going even where you can't see it. It keeps going and going and going. Okay, so indicates that the basic sine curve repeats indefinitely. And here comes Sharika. So let me get Sharika here. Okay. Uh, so, yeah, can't remember what I was saying then, but the sine curve just keeps repeating itself, and this is one period of it. Okay, now let's do the same type thing for the cosine curve. Well, I can't do that. I have to click on the screen and then hit it. Here is a graph of the cosine curve. Now, if at first glance you say, hey, that's the same curve, it's the same shape, exactly the same shape. The difference is where it begins. The sine curve began at the origin and went up. The cosine curve began at 0, 1 and goes down. Okay, but the shape is exactly the same. So one period or one cycle of the cosine curve, they started from 0, 1, went down until they hit 0, 1 again. Okay, that's one period. It could have been from here to there, from here to there, from here to there, from here to there, or from there to here. I mean, any of those would have been one period. Okay, now notice what they're saying on both of these. The period is the amount on the x-axis that contains exactly one cycle. So that goes from 0 to 2 pi, that's a period. From negative pi to pi, that's a period. From negative pi halves to 3 halves pi, that's a period. The difference there is always 2 pi. Now, what's the range of sine? Anywhere, but within that period as well, from minus 1 to plus 1. Minus 1 to plus 1. It always keeps going up and down between those two values. Never exceeds minus 1, positive 1, never gets less than negative 1. Always is in between those. How about the cosine function? Its period is also 2 pi. Whether you measure from here to here, negative pi to pi, that period is 2 pi. Pi halves to 5 halves pi, that's a 2 pi period. Any one of those is a 2 pi period. What's the range? The range is from minus 1 to 1 as well. It's just the starting point is different. Okay? Sine starts at the origin, cosine starts at plus 1. That's the difference. Otherwise, the curves are identical, except where they start. It's just basically a horizontal shift. Okay. Any questions on the graphs of sine and cosine functions? Okay. We know the domain of the sine and cosine functions is the entire set of real numbers. That's why I said before that graph goes infinitely to the right, infinitely to the left. It just keeps repeating itself over and over and over and over and over again. Moreover, the range of each function is still, no matter how far you go to the left or right, it stays between plus or minus 1. Always. Including plus 1 and minus 1, but never exceeding either one of those. So the range is always minus the plus 1. Now, each function has a period of 2 pi. They just start at different places, but each one has a period of 2 pi. Now, I've already illustrated that on these graphs. There they are again. Any questions on that? Okay. Now hang on to that concept. The period, the natural period of sine and cosine is 2 pi. Remember that. Now, note that in both of those figures, the sine curve is symmetric. There's the other one. Sine curve is symmetric about the origin. That means when you go to the right of the origin, you go up. When you go to the left of the origin, you go down exactly the same amount, but just in the opposite direction. So therefore, it's symmetric about the origin. Whereas the cosine function is symmetric about the y-axis. If you go to the right, you go up. You go to the left, you go up the same amount. Or if you go further over here to the right, you go down, go that same distance here, you go down there the same amount. Same is true for sine. Everything's always opposite. You go to the left way over here, you're going up. If you go to the right way over there, you're going down the same amount. This is reflective across the origin. This reflects across the y-axis. This is an odd function. This is an even function. Does that make sense? Okay. So the sine curve is symmetric with respect to the origin, whereas the cosine function is symmetric with respect to the y-axis. And those properties of symmetry follow the fact the sine function is odd, the cosine function is even. Okay, what I just said. To sketch the graphs of the basic sine and cosine functions by hand, and you probably will be doing some of this, hint, hint, like on the next test, hint, hint, pay attention. It helps to note 5 key points in one period. It's actually really 4, but we repeat the 2 endpoints, and they're the same. Okay? And these will define your intercepts, where it crosses the x-axis mostly, but it'll also cross the y-axis, the maximum points, the minimum points. So your sine function for one period, that's what we're dealing with, 5 points. The initial point, 0, 0. That's the x-intercept and the y-intercept. Okay? Then you go to the first max, and that's at pi halves 1. Go to your next intercept, x-intercept, and that's at pi 0. Go to the next minimum, and you're at 3 halves pi and negative 1. That's your minimum, and then go back to 2 pi 0. Now, I said that repeats. You see that's exactly one period away, so it's exactly the same value as here. So, in other words, these two, except for where they end, but, you know, the period just starting over again. So, 5 key points. For cosine, the first one, the 0, 1, that happens to be a maximum here. Pi halves 0, that's your minimum. I mean, that's your x-intercept. And by the way, the maximum 0, 1 is your y-intercept as well, but it's also your starting point and a maximum. Lots of hats it has on. This is an intercept here, x-intercept at pi halves 0. A minimum down here at pi negative 1. Another x-intercept at 3 halves 0, and then another maximum at 2 pi 1, which is basically repeating this point only one period later. And all these points will shift one period at a time. Remember, the period is 2 pi. Now, that's one way to look at it. Here's the way I usually do it. If I know it's a sine function, I know it starts at the origin, 0, 0. So I know it's got to be at 0 when you're 1 period later, 2 pi 0. Exactly halfway between that, and they call it the half period, is another 0. And halfway between the two zeros, on this one is a max, on this one is a min. That's how I usually do it. I do it by finding the endpoints of my period. Okay, let me get my hands lined up. Okay, then halfway between that half period for the sine, that's an intercept. an intercept, and then halfway between those two is a max. Halfway between these two is a min. For the cosine, since it starts at the max, it ends at the max. Okay, so halfway between those two, you're going to have a min. Halfway between those two, you have an intercept. Halfway between these two, you have an intercept. That's how I usually do it, whether I'm dealing with anything. And this especially comes in handy when you have things with varying periods. And remember I said the basic period for a sine and cosine is 2 pi. But we'll find ways, believe me, they'll find ways to change that period. And we'll talk about those later. Those are called your, from pre-calculus algebra, those would be your non-rigid translations. Okay, horizontal non-rigid translation. Okay, so those are your key points. Your endpoints, halfway between and halfway between those. So here's what I usually do. I say mark the first period, the length of the period, and then put 4 points in between. One halfway between those two, halfway between that two, halfway. So divide the period into quarters. And that's why they call it a quarter period, half period, 3/4 period. It's a little confusing because the period is 2 pi, half a period is pi, a quarter of a period is pi halves. Okay, 3/4 of a period is 3 halves pi. So it seems like you have fractional numbers there that are slightly different. You have to know what you're talking about, whether you talk about pi's or you talk about periods. And it's easy to confuse them. So that's why I usually do it the other way. So here's example 1. We're now on page 298. Okay, we already have been. Sketch the graph of this function. Y is equal to 2 times the sine of x on the period from minus pi to 4 pi. Okay, now I'll promise you my sketches are not very pretty. Okay, you can do much better, but I'm having to do this freehand, so I'm going to try to draw a horizontal line. That's nowhere close to horizontal. Now we don't have as much negative as we have positive, so I'm going to do the axis over here, the vertical axis here. Let's just pretend that's a straight vertical line and perpendicular to this one. Okay, we know we're going out here to 4 pi, so let's do that. Well, halfway between that would be 2 pi. So this is 4 pi. This would be 2 pi. Halfway between there would be pi. And halfway here would be 3 pi. Now, since I know about what a pi is here, there's what negative pi would be. Okay, and that gives me my domain. We're only interested from this point to that point. You know the sign keeps going on and on and on, but that's what we're interested in. Now, what is the period for sine? Okay, no, first question. Where does sine begin? When x equals 0, what is sine? Anybody? I thought you knew this one. It's one of our 0, exactly. So I always put that in. Okay, and what's the period for sine? 2 pi. So that's going to be 0 again here and 0 again here. Now halfway between those points, you have your midpoint is also a 0 and a 0. And since 1 pi to the left is 0, 1 to the right is 0, 1 pi to the left is 0 as well. Okay? Now, here's where a little bit of issue comes in. Now this is not to scale. this is 1, 2, 1, 2. Now, why, or negative 1 and negative 2. I can't figure out why they threw this in here without telling you what that was, okay? When sine is 0, when x is 0, sine is 0, 2 times 0 is 0. When, okay, time out again. I forgot. Go back to your period, 0 to 2 pi. I want 4 points in between that, to get my 5-point thing. So I also need my pi halves in here and my 3 halves pi. That would mean I also have to include 5 halves pi here and 7 halves pi there. And I'll need a negative 1/2 pi here. All this talking of pi is making me hungry, and here comes Courtney. Okay, let me get Courtney here. We'll come back to this in just a moment. Okay, I need a bigger desk, okay, and my cords are getting all tangled up. Courtney's here. So that has us up to 2, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13 students. Let's see if that's what we got here. Make sure nobody else is waiting. Yep, 13 students, nobody else waiting. Okay. Now, as I was writing in, Courtney, we're on in Chapter 4, Trigonometry, 4.5, graphs of sine and cosine functions. We're on example 1 on page 298, just getting going on. And by the way, this one's also at larsonprecalculus.com. If you go there, you'll see an interactive version of this type of an example. We're plotting this function here, y is equal to 2 sine x, just in the process of filling in blanks here. Okay, I've got my domain set up here because we're going from minus pi to 4 pi. So I started off doing 4 pi, did 2 pi, 1 pi, 3 pi, I did all that kind of stuff. I split each period for sine or cosine normally is 2 pi, split that into half and then into quarters, okay, in both directions, every direction. Now, I've already noted sine starts at 0, and so in one period it's going to be 0 again, and another period it'll be 0 again. So I could put those in. And also, since the endpoints are 0, it goes up and comes down. The midpoint is also a 0. So that's a 0, that's a 0, and that's a 0. Okay? Now, the other points are your maxes and mins. Okay? Now remember this, sine always starts going up. And what is the sine of pi halves? Hopefully you know that one. The phone's ringing downstairs, it's just going to have to ring. What is the sine of pi halves? Anybody? 1. But we're doing twice that. So that makes it 2 here. So this goes up at pi halves to 2. But then at 3 halves pi, it goes down to minus 2. At 5 halves pi, it goes back up to 2. At 7 halves pi, it goes down to minus 2. After that, it's all outside of our range. Over here at minus pi halves, it goes down to minus 2 again, and then you have your 0. Guess what? We can sketch the graph now. Starting at this 0, it goes down to the minimum, up to the next intercept, up to the next maximum, down to the next intercept, down to the next minimum, up to the next intercept, somewhere there, up to the next maximum, down to the next intercept, somewhere there, down to the next minimum, and up to the next and the last intercept. That's about what it looks like. Now, it's not a pretty ugly drawing, but it started off from the beginning. A couple of things to remember. These are always rounded. They're never pointed. That one's a little too pointed. This one's a little rounded, okay, but it's off a little bit. This is rounded a bit too much, but it should be rounded. That one's not too bad. That's rounded about right. And this is off just a little bit rounded about right. They're always smooth rounded curves. Never points. This isn't a sawtooth. This is a sinusoidal curve. Okay? Your max and mins are there. That was changed because you multiplied by 2. The zero stayed 0, so that's why I put them in first. Okay? But the max and mins change. Does that make sense? Now, they go through a bit more mess to get to the same things. I do it graphically. They do it in a table first and then do it graphically. Whichever floats your boat, whichever you like better, go for it. They said sketch the graph, so I started sketching the graph. They note that y is equal to 2 times the sine of x. Yeah, that's what they gave us. That was really important for them to put down. Okay? And that's equal to twice the sine of x, which is exactly what 2 sine x means. So, wow, they're really hitting on a point here. Indicates the y values are, for the key points, will now have twice the value magnitude that they had from the regular function, sine x. That's what the 2 did for you. Okay? We got there, but I did it later. I didn't start off with noticing that. Now, divide the period 2 pi into 4 equal parts, and that's exactly what we did. Okay? And that's how you get your 2 points. So you started with the 0 to 2 pi, and then did one halfway in between, one halfway between there, and halfway between there. That's your 4 points. Okay? They identify them, and they know that sine starts at the intercept, so at 0, 0, then it goes up to the max, back down to 0, down to the minimum, back up to 0. That's one curve, one period, one cycle of the sine curve. That's what they're showing here. And then you just repeat that as many times as you need. By connecting those key points with a smooth curve and extending the curve in both directions over the interval minus pi to 4 pi, you obtain the graph you have here. So they first did this one from 0 to 2 pi, 0, 2 pi, 1 pi is another 0. Halfway between that pi halves, you have a max. At 3 halves pi, a min, and then repeat the process. From 2 pi to 4 pi, same thing. Halfway in between, another intercept. Halfway in between there is a max first and then a min. Going this way, you only have half a period there. Because a period is 2 pi, you're only going minus pi, so you only do 1. And since it's coming down here, you continue down, and that gives you a min there. Now, I would have put dots here, here, and here as well, and here. I don't know why they put dots every place except that one on the x-axis. So they're just being a little inconsistent. I put them in everywhere and then connect the dots. Now, what they showed you here, here is your basic sine curve. The period, everything is the same. The difference is it only goes up to +1 and down to -1. The 2 in front tells you double everything. Well, double 0 is still 0, so these still intersect at the nodes there, including that one. But everything else, see, that is twice this, that is twice this, certainly that is twice that. Every point is twice as high as the corresponding point under it, or twice as low. Right here, at this value here, you're negative this, you're exactly negative twice that down here. Okay, everywhere. So you just draw the curve in between. Do it the best you can. Any questions on that? That's example 1. Now, there is a checkpoint after every example. Please do the checkpoint as soon as you can after class. Now we move into amplitude and period. Now, frankly, in my mind, that example should have been after we dealt with amplitude, because that's exactly what that 2 was. That was your amplitude. For the rest of this section, we'll study the graphic effects of each of the constants A, B, C, and D in equations of this form. And this, again, I can't figure out why they do it this way, maybe a little bit of a hint. Y is equal to D plus A sine BX plus C. Now, I don't like working with that form. I'll show you the form I prefer, and it's mostly just cosmetic, but there is some contentious. Okay, I would have read, because I like A, B, C, D, I would have said A times the sine. Now, being a physicist, I do the B on the outside, X minus C on the inside, and then put my plus D out here. And why in the world they put the D in front, I don't know. It's fine, but maybe just to keep you from confusing it. Now, the other thing is a bit more of a reason here. These are not the same C's. That is the same B's, but these are not the same C's, because if you were to multiply this, that'd be BX minus BC. So what they're going to have to do in their form is take this C and divide by B. If you go on and factor out the B to begin with, you don't have to do that division down here. But you probably don't know what I'm talking about now, but that's why I like this form better. And this is what we would use in physics more than this form. Same thing here. This works perfectly fine. No sweat. We'll handle it. Now, that constant factor A, both of those A's and this A, they're all the same A's, in y is equal to A sine X or A cosine X, that is called a scaling factor or a vertical stretch. That's exactly what our 2 did before. It stretched the sine curve vertically, up and down equal amount. That is your, and that feature of that. Now, when that absolute value of A is greater than 1, that is a stretch. However, that absolute value of A could be less than 1. That could have been a half or 3/4 or 0.4, or something like that. Then what you do are you're shrinking the sine curve, shrinking the max and min. If it's greater than 1, you're stretching them. Less than 1, you're shrinking them. If it's 1, it's the same. It's, you don't have any stretch or shrink. Okay? Basically, just like we did before, this is a goodness gracious, non-rigid translation. That's what it's called, non-rigid translation. Okay. The result of that is that the graph of y is equal to A sine X ranges now, instead of between plus and minus 1, between plus and minus A. Minus and plus A, instead of between minus and plus 1. Because the sine itself, if you wiped out the A here, this goes between plus or minus 1. You multiply it by A, it's going between plus and minus A. A could be a smaller number, that means it's a narrower range, or a bigger number, that could be a bigger one. The absolute value of A is called the amplitude. So in our previous example, that was 2. Okay? Now, the range of the function, A sine X, y is equal to A sine X, or A cosine X, for A greater than 0, and usually we do keep our A, well, no, we don't have to. The range of that would be between plus and minus A now, rather than plus or minus 1. Same thing they're saying up here, they're saying it here. So here's your definition of amplitude of sine and cosine function. The amplitude of a function, y is equal to A sine X and y is equal to A cosine X, represents half the distance between the maximum and minimum values. Before, you remember that was between minus 1 to plus 1, so that difference there is 2, half of that is 1. 1 would be your amplitude because it's y is equal to sine X or y is equal to cosine X, coefficient of 1. Now, the A is half the difference between the maximum and minimum values, and that would be what we call that. And it's just the letter A. So the amplitude is always the absolute value of whatever the coefficient is in front of sine. That could have been a positive number or a negative number. It could be a small number or a big number. The amplitude is the absolute value of that number. Okay? Now, let's go back. The graph of y is equal to minus f of x, remember from precalculus algebra, that's a reflection across the x-axis. For every y value that was up here, it now gets negated. For any one that was down here, it gets negated and moved up. So it's a reflection across the x-axis. Okay? So, if you had the graph of y is equal to minus 3 times the cosine of x, you could do it in two steps if you wanted to. Cosine x starts at plus 1 and goes down between plus or minus 1, just like that. Okay? But if you have 3 times the cosine of x, then that goes up 3, down to minus 3, up to plus 3, down to minus 3. But if the minus is in front of that, that flips it across here. You're starting at minus 3, going up to plus 3, down to minus 3, up to plus 3, and so on and so on and so on. Your zeros stay the same, you know, because where cosine is 0, y is still going to be 0. Okay? It's just anything beyond the zeros are going to be stretched. The minus sign just flips it across the x-axis. Does that make sense? Okay. My throat is clogging up on me, or my head's clogging up on me. I think this rain and everything else is sort of getting to me. Because y is equal to a sine x completes one cycle from 0 to 2 pi, just like a sine x, y is equal to sine x did. It follows that, excuse me. Okay, sorry. I think the temperature is dropping outside. Excuse me. Because it sure feels like it's dropping inside here too. Okay. Thank you. Did I wake you up? That's the whole purpose of that, by the way. Never mind. I'm just kidding. All right. Here we're jumping a new rabbit here. We were talking about amplitude. Now we're going to talk about something else. What we're going to do is not just have an A in front, which is an amplitude. That just is a vertical stretch. What we're going to do now is multiply the x by something, which is going to be a horizontal stretch or shrink. Okay? Now, I don't know if you remember from your precalculus algebra, but whatever you're doing to y's, go just like you expect. A big number, A, is going to make a big stretch. A small number is going to make a small stretch. However, whatever you're doing to x is always backwards. A big B is going to be a horizontal shrink. A smaller b is going to be a horizontal stretch. Backwards, but x is always backwards. Okay? So y is equal, here's what they're saying. Y is equal to a sine x completes one cycle between 0 and 2 pi. A sine bx completes one cycle between x equals 0, well, between bx equals 0 and bx equal to 2 pi. Okay? So what you do with bx equals 0, just divide by b and it's still 0. But bx equal to 2 pi, divide by the b, and that gives you your period. So the A is your amplitude, B isn't your period, but, well, A isn't your amplitude. The absolute value of A is your amplitude. B tells you that something's changing with the period. Okay? What does that change? The period changes to 2 pi over B. Where B is, and by the way, B is always positive. A can be positive or negative. B always positive. Don't ever mess with a negative B. That just is a reflection across the x-axis, and that's really not accomplishing much. And you don't ever want b to be 0 either, because sine of 0 is always 0. That's just flat line. That's not very interesting at all. So here's a definition for period of a sine and cosine function. If b is a positive, not 0 and not negative, positive real number, the period of y is equal to a sine bx and a sine cosine bx is given by period is 2 pi over b. So it's an inverse relationship. Big B's make smaller periods, smaller B's make bigger periods. Inverse. Note that when b is between 0 and 1, it can't be 0. At 1, it's just a regular function. Then the period is greater than 2 pi, horizontal stretch. And if the b is greater than 1, that's a horizontal shrink. So anything dealing with the x is always backward from what it was with the y. Okay? So, any questions on that slide? Similarly, when b is greater than 1, now afraid I'm going to have to sneeze again. I'm going to try not to. When b is greater than 1, the period of y is equal a sine bx is less than 2 pi, because you're dividing by a bigger number, and that gives you a horizontal shrink of the graph of y is equal to a sine x. Now when b is negative, then you use your identities. Sine of negative x is minus sine of x, and cosine of negative x is cosine x. You just rewrite the function, get rid of the minus b. You don't like a negative there, so just rewrite the function like this, and now your b is positive again. Here the b is positive again. So if you do happen to have a negative b, just rewrite the function using the oddness of sine, the evenness of cosine, and go from there. So here we have sketch the graph of y is equal to x sine of x over 2. Now what I get into the habit of doing, mostly for your sake, I start writing down. What's your a here? What's your coefficient of sine? 1. What's your, yes, what's the b here? What's the coefficient of x? No, 1/2. 1/2 times x. X over 2 is the same as 1/2 of x. That's your b. Now, the a relates to the amplitude, so the amplitude is the absolute value of 1, which is of course 1. The b, however, relates to the period. And how is the period related to b? Two pi over b. You're absolutely right. So that would be 2 pi divided by b is 1/2. Now, I don't know how good you are with your fractions. When you're dividing fractions, you invert and multiply. So this would be the same as 2 pi times 2 over 1, which then would be 4 pi. So there's your period, 4 pi. Okay, sketch the graph of that. They didn't say between what limits, so we'll just put our vertical axis right down the middle and try to do a horizontal axis here. Neither of those are vertical or horizontal. And since we're going to need at least 4 pi to cover one period, let's just start out here and make this 4 pi. Okay, that will make this 2 pi. That will make this pi. And that will make this 3 pi. Now I'm not really very evenly dispersed. And let's try to get the same things here. That would be a minus pi. This would be a minus 2 pi. Approximately, I'm just drawing freehand. Minus 3 pi. And somewhere out here is a minus 4 pi. So that's actually going to give us 2 periods. Okay? Now, Your amplitude is 1, so you know you're going only up to +1 and down to -1. That's all you're worrying about with it. That's what the amplitude tells you. Okay, this is 1 period then. Once you get your period is equal to 2 pi. 4 pi, that's what you got here. Bringing those together. Next thing you do is then divide by 4. So your interval that you're going to use is pi. Not pi halves anymore, but pi, because this is the interval you're going to use. Well, here you got them right there. I use them for drawing, but that's your interval. So you know sine starts at 0, and therefore 1 period later will be 0. And 1 period on this side will be 0. And then halfway between those zeros, you have another 0 and another 0. Now halfway between those, you have, since there is no minus sign here, for A, you're going up to 1 and down to -1. Down to -1 and up to 1. There's your points. Connect the dots. You like to play that game when you were younger? Connect the dots. See what drawing comes out of it. Let's see what we get. We get a sine function with a horizontal stretch. There you have it. The horizontal axis has been stretched. Vertical axis is what it normally would be. That's your thing. Now, if you had drawn your plain old sine function, then that would have been going from 0 to 2 pi. You would have had another 0 here. At pi halves, you would have had your 1. At minus pi halves, you'd have had your -1. So your regular sine function would have been like this. I'm not going to draw them all, but see, this is a horizontal stretch. You took that sine function and stretched it out horizontally. Doubled it. Okay? That's why the coefficient was 1/2. Okay, any questions on that? All right. Now again, they do it somewhat bizarrely. Oh, let's see. Yep. I'm sorry. This was example 3. We skipped example 2. Sorry about that. Let's go back and do example 2. I can't even find that. Definition of amplitude. Oh, this is way back. Oh, here it is. That's where example 2 should have been. Sorry about that, folks. I was trying to watch. Let's do example 2 here, and we'll go to the whiteboard to do example 2. And of course, okay, I've got to do some housekeeping here. I'm going to scoot this taskbar out of the way. Okay, and I'm going to scoot the whiteboard on my screen as far left as I can do it. Oops, a little too far. And as far up as I can do it. And that gives me the most white space. Okay, here was example 2. In the same coordinate plane, sketch the graphs of each function. Okay, y is equal to 1/2 cosine x. I was wondering why they were leaving out cosines. They didn't. They just skipped it on the slide set. And b is y is equal to 3 cosine x. This is before we introduced period. Okay? Well, a change of period. The b's. Okay. Now, I'm kicking the legs of my desk. Okay. I'm going to start here, and that's all they say. On the same coordinate plane, sketch the graph of each function. Now I'm going to cheat a little bit. Okay, I'm going to first sketch the graph of cosine x. Now, what color would you like me to do cosine x? You choose. Oh, you can't see my colors. I have lavender or purplish, red, pink, brown, yellow, orange, some sort of dark orange, sage green, bright green, dark green, middle blue, Carolina blue, and dark blue. Pick a color. Anybody. Yellow? Is that what you said? Okay, so that's going to be yellow. That's going to be my y is equal to cosine x. I'm going to plot that first. Now you pick another color for the 3 cosine x. I didn't think to write it that. I'll circle it. Pick another color. Lavender, red, pink. Lavender. Okay, I thought about had it. There I have it. So this one will be our lavender color. But we'll get to that later. So let's go back to yellow. It's not very mellow, but it's yellow. All right. Now, since you're only dealing with x here, then the normal cosine x, has a period 2 pi. So let's make this, oh, let me go back to black here. Okay, so this will be 2 pi. This will be pi. This will be pi halves. Okay, because I know I'm going to split this into quarters. Okay, this will be 3 halves pi. Over here will be about minus pi halves. This will be about minus pi. This will be about minus 3 halves pi. And somewhere out here will be a minus 2 pi. I'll say it's somewhere there maybe. Okay, I don't have them very evenly spaced. Okay, now let's get the sine function first. Let me get, scratch that. Yuck, this thing is so aggravating. You go to erase and it just changed. Okay, it changes on. There we go. All right. Are we still black? I don't remember. We need to go up to 3. So let's do 1, 2, 3, minus 1, 2, 3. Okay. Now, let's go back to yellow now. Oh, yuck. All right. This aggravates me. It erased the last thing I drew, which happened to be the 3, so I'll put it back in yellow. I'm not going back again. Okay, cosine. We know the normal cosine function, this one right here. Come on, pen, get in the game. This one right here starts at 0, 1, go down to 0, down to minus 1, up to 0, and up to 1. That's its 5 key points. So going this way, it goes down to 0, down to minus 1, up to 0, and up to 1 again. And that's something like this is your normal cosine curve. Whoa, that 1 is way out of place. That should be right here. I don't know where I was going there. So let me see if I can erase this and that. Okay. That's their normal cosine curve. So let's go to the black curve, which is your 1/2 cosine. Is it time? You're kidding me. Let's do this real quickly. 1/2 will only go to plus 1/2 here, minus 1/2 here, plus 1/2 here. The zeros stay the same. 1/2 of 0 is 0. So this will be 1/2 there, negative 1/2 here, 0 there, and positive 1/2 there. So there is your vertical shrink there's that one. Then the lavender one, okay, the lavender one goes up to 3. 3, but the zeros stay the same. So it goes down to minus 3. The zeros stay the same, goes up to positive 3 there too. Okay, 0 is the same, negative 3 down here, 0 the same, and up to positive 3 here. So that's going like this. Vertical stretch by 3. That's what happens when you change your amplitude. Ooh, that one's going off, isn't it? These are always supposed to be nice and smooth at the top. Any questions on that? Sorry that we ran out of time, but that was example 2. We did both parts of example 2. We've already done period. We already did example 3. So we'll be starting next time on page 301, translations of sine and cosine curves. Okay? All right. That's on page 301. Let me mark my place in the book so I don't forget this. And homework exercises here would include any of the odds 5 through 11. Oh, wait. Yeah, period and amplitude. We did some of both of those. Some of those are a little more involved than that. Okay? I think you can begin doing some of the odds 13 through 23 now. No, I'm sorry. No shifts. 13, yes. 15, kind of, yes. 15, yes, but not 17. So only 13 and 15 there. They're both a Calc Chat. Okay. The first one's 5 through 11 at Calc Chat. 7's a Calc View. All right. Any questions? Sorry we ran over, but guess what? There'll be no extra charge today. So any questions? All right. Let me stop sharing. It wound up being a pretty small crowd today. What did we get up to? 12 students. Make sure I got 12. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. Actually, we're up to 13. We've already lost some people. So anyway, one person. All right. So if no more questions, we're going to end the meeting. But please be safe, people. Please be careful. The virus is still going around. It's going to be rainy for a day or two here, so take advantage of it. Stay inside. Get your trig done. Get your research papers worked on. Get your homework. Work on that test. You all know where it is now. Any questions? If anyone came in late, you can go to the first part of the YouTube video. It won't be posted until this evening sometime, but anytime after tomorrow you'll be able to get it. So you can find out where to get the test. We went over that early on. Any other questions? Take care.
Can you explain the outlines in the research paper again?
Okay. Say again.
The requirements.
Okay, requirement. You pick a topic. It has to do something with trig. And you find one or more outside sources, more or better, but at least one outside source. That means your book can be a great idea, a source for ideas, but it can't be a source for your paper. You have to find something outside your book for your sources, okay? And you write me a 1 to 2 page paper, double space, normal font, 12 pitch, 12 point, double space, paper. Doesn't have to be anything elaborate. Just get it. Now, if you go over 2 pages, no penalty. Less than 1 page, penalty. Okay. You need to get it in before the end of the term. If you get it in this month, the month of September, we don't have much September left, you get 3 bonus points. October, 2 bonus points. November, only 1 bonus point. December, you just get your score. Okay. You follow whatever format you learn in English or you like to use, whatever that is. It's all out there. If you go to the very first week 1 in the PowerPoint and the Blackboard, and scroll down and you go to handouts, one of those handouts is REPAGEIN, research paper general instructions. Okay, there it is under handout. Okay. You can also go to the first day of class, which we didn't get to record because they hadn't paid the bill. But if you go to the first day of class in the last spring, and that's in there on the Blackboard, on the YouTube videos, you can hear me talk to you. Sick of hearing me talk about the research paper, so it's all there too. Just go, it's either the syllabus or first or second class that we did last spring. That's up in the upper part of the YouTube recordings. The lower parts are the current ones, the upper parts the older ones. So it's either syllabus or the next day up there. Okay, that was quick and dirty. Did that answer sort of what you needed? Okay, good deal. All right, any other questions before I close the meeting? Yeah. Okay, test and paper, either one of them. Okay, you have several options. You can, okay, the paper, I'm guessing you could do it probably in a Word file. I'm guessing that's what you would choose. If you did, you can email me that Word file. You can send it through Blackboard message, either one. Okay, the test. Now, I sent it to you, I think, as a PDF. So it's going to be hard unless you type the whole thing out to send it back as a Word file. Unless you just want to do your answers as a Word file, that would be okay too. But I really like to see your work. So I can give more partial credit if you miss the answer, but you got the work. Basically, you're going in the right direction. You may just made a dumb mistake. I can give more partial credit. So you decide what you're going to do. You can send it to me in an attachment as an email. You can send it to me as an attachment to a Blackboard message, or in that week 6 test 1 place where I couldn't put the test, you can send it to me that way if you can figure out a way to do so. I don't know Blackboard that well. This new version and this new template is really awkward. To me, I'd say attach it to an email or a Blackboard message and send it to me that way. Now, you can send it to me as a PDF. You can send it to me as a picture, a JPEG. Just be careful for those things that are too fancy. Some people have sent me things with HEIC. I don't even know what suffix that stands for. My computer or Blackboard won't open it. So try to keep it, if you do a picture, a JPEG or something like that, a PDF is great. If you type it out, the answer is a Word document's fine too. I really don't care how you get it to me. Get it to me the best way you can. If I can't open it, I'll send back something, either email, however you send it to me, I'll respond to it the same way and say, hey, I can't open this. Can you send it to me either as a JPEG, a PDF, or Word document or something like that? Does that answer that one? Okay. Any others? Great questions, by the way. So if there are no others, I'll go on and end the meeting for us all. Y'all have a good, safe, healthy, trig-filled weekend, okay? We'll see you Tuesday. Bye-bye.